Hello and welcome to this section on graphing. Graphing is a review for everybody. You already know about this, but it's important that you know how to graph your data. Why? Makes it a lot easier to understand. First of all, what if we took all this data, we drop an object, we record all this information, all this data. This column here represents the time in fractions of a second. And at that particular time, this is the position that object has traveled down in centimeters. What if, and then these are the different dots on the graph, but what if we had all this information just spread across the page? What a mess. This chart makes it much more organized, and I'm going to just remind you always, 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 always when you make tables and charts in your labs, always label them. This number means nothing if I don't know what it is. And not only if I don't know what it is, but I need to know the units. What if this position were in something like kilometers instead of centimeters? That would give me a totally different idea of what was happening. So you always label it, always, always, and you always put units. But the graph itself is even more dynamic because it gives me a visual representation of what is happening. It allows me to detect patterns that are going on with my data. So for every little bit of time, this is the distance that object has fallen. You can see that it is increasing probably in how far it's traveling for that amount of time, isn't it? It's actually gaining in speed. So here's some different types of graphs. We have a line graph. We have a bar graph. We have a pie graph or a circle graph. We're going to look at each of these different types of graphs and how we make them. Let's start with our line graph. That's probably one of the most useful. We're going to be using this a lot this year. In a line graph, we are comparing two sets of related data. It helps us to predict data that's not directly measured as well. If we have a line, we can then look at places in between those points on the line or beyond the point on the line to predict what data would be for those points on the graph. So how do we make a line graph? The first thing we need to do is determine our variables. So let's use an example and follow it through. Our example will be, let's find out how long it takes to boil water and heat the measured amount of the water over a Bunsen burner and record the temperature every minute. So we're going to get some data every minute. For every 1 minute that goes by, we're going to get data of temperature. Okay? What are our variables? We need to determine the dependent and the independent variables. Well, what is it that we are changing? We're changing time. As time goes on, at 1 minute, we're going to record the temperature. At the next minute, we're going to record the temperature. And at the next minute, we'll record the temperature. We're going to put time on the x-axis. Usually, when you are recording something over time, time will go on the x-axis. That as you go across to the right, over time, you're going to record the things that are changing. So here is the heating time. That's what we're changing. And here is our water temperature that will be on the y graph. And we label those. We determine them. Now we're going to determine the scale of our axes individually. What is the scale for the heating time? We're going to look at our data. We did 5 minutes of heating time. And we need to spread that out evenly over the distance of that x-axis. We don't want to say 1, 2, 3, 4, 5 and bunch it all up in this little tiny corner. And we don't want to have the scale so big that 4 is over here and we don't have room to put 5. Likewise, we need to determine the scale for the y-axis, which will be these values. We need to get all the way up to 100, maybe a little past 100, so we're not at the very tippy top of our graph. And we equally distribute those over the y-axis. We need to occupy that available space, and a good way to do it would just simply be to take the largest value and divide it by the number of squares because you will have graph paper. So that's one easy way to determine that. We're going to number and label with units, degrees C and minutes there. Next, I plot my data. So I look at my data over here. At 0, I'm going to have 49.5. I plot that data. Each of these data points will be a point on my graph. Then I draw a best fit line. This one's easy. This is a very, very linear. We're going to look in the next frame at some examples of how to draw a best fit line. But the last thing I want to do, title my graph. Always, always, always include a title to your graph. It does not need to be fancy. Simply water temperature versus time. You can simply say, whatever the label for your x-axis versus whatever the label for your y-axis versus your x-axis. That can be the title for your graph. Provide a key also if there's more than one set of data. Let's say you did this several different times, maybe different elevations. I don't know. You're doing something different and you're going to get different lines. Let's say that would happen. Then you would need to provide a key and tell which, maybe you could color them or indicate that they're different somehow and indicate that in your key. So back to this idea of a best fit line. Here are just some examples on different graphs. You can see that the plots here, they put as x's, and the point where that x intersects is the point. How would I draw a line? This would be the best fit line. Here is a best fit line for this data right there. Here is a best fit line for this data. It takes into consideration all of the data points, and it's kind of like an average between all of those. Sometimes, however, the best fit follows a curve, not a line. Here, we can see that it's a curve. This is an anomaly. This is sometimes one of your data points will be wildly different than the rest, and it will not participate in your determination to make a line or a curve. Here is also another best fit curve. Next kind of graph, let's look at bar graphs. Bar graphs, we're also comparing two sets of related data. In a bar graph, however, one of the sets of data is usually a category rather than a numbered value of something. For example, categories, different students, or different categories of types of movies here. Another thing, a histogram, technically a histogram is comparing only one variable. This is technically a histogram because there's only one variable, the type of movie and how many students choose that as their favorite. This would be a bar graph comparing two different variables without preparation and with preparation, scores on a test with or without preparation. So on a bar graph, you want to determine your variables, just like we did with the line graph. We determine the scale of the y-axis. We're not going to have a scale on the x-axis because the x-axis is just going to be the different categories. You're going to number and label each of the axes with units. Use the data to create little bars on your graph. And you can color those bars all the way up or shade them in or however you want to do that. And last and not least, title the graph. Also provide a key if there's more than one set of data, just like they did right here. Circle graphs. A little bit more work to create one of these. But a circle graph or a pie graph shows how a fixed quantity is broken down into parts. Here's an example of a circle graph, trash on the beach. So someone evidently collected a bunch of trash on the beach and they're looking at the percentage of the different types of trash and they're representing it on this circle graph. Now, in order to set up your own and create your own circle graph, you're going to have to do a little bit of calculating. So let's look at how that works. How would you do that? First, you'd begin with the total of what you're analyzing. So let's say in our data for this circle graph, 152 pieces of trash were collected. So that's our total. 152 is the total pieces of trash. We're going to then draw a circle with a compass to represent the whole, all 152 pieces of trash. The next thing we're going to do, we're going to determine the percentage of the whole for each different quantity. So let's say that we are told that 61 of those pieces of trash are cigarettes. What percentage of the trash is cigarettes? Well, 61 pieces are cigarettes. My total amount pieces of trash is 152. I know that 61 divided by 152, when I punch that into the calculator, is 0.4. I can convert that into a percentage by saying 0.4 times 100. That's going to give me 40%. So I know that 40% of the trash was due to cigarettes. So to draw the graph, I am going to now how am I going to represent this 40% on this graph? I'm going to have to correlate that with a certain number of degrees. So my example, my 0.4, I know there are 360 degrees in my total pie graph. If I take my fraction, the 0.4 number before I turned it into the percent, 0.4 times 360 degrees is going to give me 144 degrees. So I would take my protractor, I'd lay it down on my pie graph, and I would mark off 144 degrees, and I would draw that in, color that in. That is going to represent 40%. And I can label that 40%, and in my key, I'm going to label what that 40% is due to, the cigarette trash. So I'd color that some color and use a key to indicate that that is what I am talking about. So last, I need to label, I would do that for each of my individual components. I'm going to then label the graph with the percents, with the keys, and I'm going to make a title for my graph, and that's how I would make a circle graph. So an advanced idea would be create your own circle graph. Here's some data that I gave you, or you can collect your own data and come up with your own idea for your circle graph and make that for advanced proficiency. This particular data has to do with the amount of electricity generated by different sources within the United States in the year 2013. Tells you how much billion kilowatt hours each of these sources contributed, and you can make a really nice visual pie graph out of that. So look forward to seeing you in class.